Oh, hi there. I was just playing my flight simulator here. But, hold on a second. What is flight?
Flight, or better known as lift, is the reason why 80,000 kilogram aircraft like this can fly, how the space shuttle can return back to Earth, how birds can soar, how sports cars can stay on the ground, and how tiny little dragonflies can still manage to buzz around.
Now, in order to understand lift to its fullest potential, we have to understand what an airplane is first, and we're going to start it off really simply by talking about something called the four forces on an aircraft.
Now, every aircraft usually has four forces acting on it, either thrust, lift, weight, and drag. We're going to be focusing primarily on lift for this video and how it's generated.
Now, there's a couple of things we have to understand before we dive into lift. Two things: downwash and pressure.
Let's take a moment to talk about pressure. No, not quite this type of pressure, but the pressure that affects lift. This kind.
Now, if you're cool enough to recognize this guy as Daniel Bernoulli, you might also recognize his principle, called Bernoulli's principle.
Take a second to look at this animation here. The green stuff on the top and the bottom are the actual air particles moving over an airfoil. And as you can tell, the particles moving on top are moving much faster at a higher speed than the particles on the bottom. Now, according to Bernoulli's principle, that means there's a lower pressure on top and a higher pressure on the bottom, which gives you a low and high pressure system, which generates lift because the higher pressure on the bottom is pushing the wing upwards. Now, if you still don't quite get it, here's a little analogy to kind of help out. Imagine you have two people. Red one's a lot faster than the blue one, so they're running really quickly, and the red one's displacing a lot more air because he's going so fast. This creates your low and high pressure system.
Now, you might know the name Sir Isaac Newton. He's this guy. And he also came up with the famous 3 laws we see in high school. These.
Now, while keeping Sir Isaac Newton in mind, we're going to talk about something called downwash. It's another huge part of lift. It actually utilizes Newton's third law, which is for every action there's an equal and opposite reaction. But there's something we have to understand first, something called camber. Now, camber really just means curvature of the wing. It determines what the upper and lower parts of the wing kind of look like. Now, if you take a regular airfoil like this and pass air over it, you'll see that as the air passes on top, it kind of curves downward at the end. Same thing with the bottom. This is called downwash. Now, as you know, with Newton's third law, for every reaction there's an equal and opposite reaction. The air pushing downwards pushes the wing upwards, giving you your thrust and lift forces. Now, you probably just heard me say thrust, but what does thrust have to do with lift anyways? Well, for gliders and sailplanes like this, lift is important because it generates a bit of thrust through downwash that helps propel them forwards during flight. So now that we've taken out the whole mystery behind lift, it's easy to see how such small things and huge things like these jumbo jets and airliners all rely off the same principle of lift. Thanks for watching.